This is part 3 of chapter 1, the introduction. So we left off talking about ecosystems and how change is inevitable and essential for ecosystems function. But there's also something that we need to talk about, which is how can we as humans act sustainable? And so the well-being of present and future humans depend on acting sustainably. If we use all of our resources now, then future generations will not be able to survive, which means the end of the human race. The other thing is that we need to be able to act sustainably, act within, remember, sustainability means that has the 3 P's to it. So we need to be able to figure out ways, which is people, profit, planet. We need to be able to figure out ways that we can still use resources and function as a human society, but we also need to think about everything else that lives within it. I know it's a hard task, but it's just something really simple. Well-being of present and future humans depends on acting sustainably. Understanding of ecosystems is essential. This is one of our hardest things that we have as humans, is that science can be difficult. It can be complex, and sometimes we're ignorant to it. So what we do sometimes is we just decide not to learn it because it's a little bit more complex to learn. And that's a big problem. So if we can learn a little bit more about how ecosystems function, then we can act more sustainably as a human population. And our actions should not disrupt the functions of the ecosystem as a whole. So for example, if we build communities in the desert, then we need to understand that when we build these communities in the deserts, we need to understand what those populations are going to need and how we can create those populations without destroying the ecosystem. And this is really hard to do. But if you want to live in the desert, then maybe you need to cut back on your water consumption. Or maybe you need to install solar panels on your house because the sun is so vivid, so electricity use is just not as high. Rather, instead we use solar energy. So there's just lots of things that we need to think about when we create human populations and how we can act more sustainably in these areas. We can manage resources more sustainable. Sustainable actions must conform to a law of mass and energy conservation, remember. So we need to, there's an amount of an ecosystem declines with virtually any level of use. So in the scale of human history, oil is a non-renewable resource, and what we've done is we've actually cut our oil resources in more than half. We've used that much oil, and oil takes billions of years to create. So what we need to do is, remember, matter is neither created nor destroyed, so we need to figure out ways that we can do this. So not using as much oil, relying on non-renewable resources on renewable resources instead of non-renewable resources. So the problem is that we as a society created and started using non-renewable resources first. So for us to switch over to renewable resources, and we'll learn about this in those chapters, is going to take a huge change in our behavior as humans. It's going to require us to learn new technologies. It's going to require us to adapt more easily to new technologies. And so I think your generation might be a really good generation to do this because a lot of people who are ingrained in what they used to do have a hard time with change. We also have to understand boundaries. Boundaries cannot be arbitrary. State lines. We have to remember that a river doesn't just stop here. That river flows down. So if we use all the water upstream, then what about the downstream areas that are affected? Remember, boundaries must be functional. Rivers include their entire watershed, and a watershed actually looks like a vein. It is amazing how many tributaries off of the main river system there are. And actually, if we look at that throughout the whole United States, there's actually, the entire United States is covered. There's only a couple main watersheds, right? Like the Mississippi watershed, the Delaware River watershed. But these watersheds actually then have rivers onto those, and then they have streams, and then they have intermittent streams, so they're all tied together. We need to maintain balance and integration. Actions must incorporate the complexity of the ecosystems. Remember, we must embrace change, we as well as ecosystems. We must not ignore change or interfere with the capacity to change. We must avoid changing tempo of natural change. Copying nature is a big issue, so there's a lot of things that we need to be aware of, and looking for thresholds of change. So we need to look out and see what a threshold of change is and how much that can happen. So you know, we need to know what those tipping points are, and we need to realize, like, for example, there's things called indicator species, like sharks are indicator species. These are species that tell us that if we see there's something wrong with sharks, then that means that there's something wrong with the whole entire ecosystem as a whole. And this is a really good just picture of the movement of sand, is that, you know, don't forget, accelerated erosion. We have to realize that maybe some of those houses shouldn't be rebuilt there. So if a hurricane knocks away houses in a certain area, maybe those houses shouldn't be rebuilt there. Maybe they have to be rebuilt somewhere else, because we need to get used to that change. So here's some of the reasons why we as humans have a hard time with science. We have a little, when we have uncertainty, we get a little nervous about things. So we are ignorant a lot of times to ecosystems and to environmental science and to anything science-based. We just don't know enough. And sometimes when we're ignorant to something, we just kind of are like, it's better if I don't know. And of course, ecosystems are complex. So it takes a little bit more to understand an ecosystem. For example, you know, you use a plastic bottle. You say, well, I recycle it. Well, where does that recycling go? Most of our recycling actually is transported overseas to third world countries where it's burned. And the reason it's burned there is they have lax environmental standards. So we have to understand all the different complex processes of what we're doing. And this is a great indicator, is that sometimes you'll understand that when you listen to the news, or when you look at the weather reports, sometimes you're like, wait, I don't understand why this front's coming in to knock this front out. And if we can just make it a little bit more simpler for us to understand, maybe we'll be able to retain the information in a more equitable fashion. And so this is a really good image that shows you that, you know, meteorologists to predict weather a few days in advance. However, weather predictions for the next month or year are really uncertain. And a lot of times we don't like that. We want to know. We want to know right now. And right, you hear that a lot in the wintertime when the newscasters can't tell us how much snow we're going to get, or they cancel school and we get no snow. We get angry at the meteorologists, right? And the problem is that it's nature. We really have no say over nature. And so, you know, we can't predict the future, and it's complex. And when things are complex, we get mad about them. We want to know. You tell me exactly how much snow am I getting in my neighborhood tomorrow? And the meteorologists, they can sort of predict that, but they can't always get it right. So one thing that we could do is to reduce that uncertainty with science that we are worried about. We use the scientific method, which is a wonderful source. And it's scientific thinking, which is systematic questioning. So what we do is we create a hypothesis. We say, why is my pencil not working, right? And then we do experiments and we try and figure out why that happens. And then we repeat those experiments to prove it over and over and over again, what the results are. One of the really cool things about science is that sometimes our best discoveries are made when we're proving a hypothesis wrong. So we think one thing is true, but on the other way, it actually comes out false and it helps something else. And so we need to understand that. So the scientific method, sometimes it's 7 steps long, sometimes it's 9 steps long, depending upon, of course, what textbook or what guide you're using. But the scientific method is you ask the question and then you make a hypothesis. So you say what's going to happen. And then you, of course, make an experiment. You repeat that experiment, you make your conclusions, and then you publish your research. And a lot of times then someone can repeat your experiment, and if they can repeat your experiment the same way over and over again, then we know that that item is true, okay? But don't forget, anything can be proven wrong at any time, right? So for example, the theory of plate tectonics, which is how our land continents have gotten to be where they are, wasn't even discovered until 1960. For years, people thought that gravity did it, where the Earth was spinning on this rotation that was almost like the gravitron, and that's how the continents split, was that they were like forced apart. But really, it has to do with plate tectonic, with magma shifting and these plates that slide next to each other or move apart. And so it's just really interesting that not until 1960 was that theory proven to be the most accurate way. But it doesn't mean in the future someone can't prove that wrong. Okay? And so this is a really wonderful little thing that talks about the scientific method and the steps that you do. So you ask a question, well, you can make an observation, then you ask a question, you do some background research, then you make a hypothesis. Okay, so is this true or not true? You test it with an experiment, you analyze those results. If your hypothesis is false, if it doesn't come out right, then you can rethink and try again and make a new. If it's true, then you want to report those results. Those results are then replicated by others, and then new questions might come out from those reports. So this is a very good way of taking that uncertainty out of science. And when we think in this systems thinking, we recognize the connections of parts into the system. Hey, oh wait, this actually involved this, and it created, maybe we don't realize that drinking water might affect a pill that we're taking. So we realize that during the experimental phase. Well, wait a minute, why isn't the pill working? Oh, maybe it's because the person's drinking this much water. So there's all these different things. We understand more how the system works as a whole, and individual parts are important, but the overall system effect is the most important thing. So sustainable science, this is what we need to move towards. We need to move towards stop thinking in this micro but in the macro level, and we need to start thinking, sustainable as a whole, meaning now and the future. We need to start thinking about not just now. We need to think about this ecosystems as a whole, thinking into the future. So sustainable science studies ecosystems, social systems, connection, long-term trends, the ecosystem as a whole, and the social system stability. So there's a lot that we need to talk about. This is Hurricane Katrina in New Orleans. It was, don't forget, the reason that this hurricane happened was because there was an increase in loss of wetlands around New Orleans, surrounding the city, and these complex ecosystems, remember those wetlands would have blocked or knocked down that hurricane little by little, but we wanted to build up New Orleans, and this created a major problem. So we also have to understand these thresholds of change, and we talked about that. Remember, what is that threshold the environment can handle until it tips over and then we're in major trouble? So right now, our ecosystem is showing warning signs of climate change, right? And we need to realize that our ecosystem is in stress right now. What can we do to help that? Can we stop it from happening? Probably not at this point. How can we adapt to those changes? How can we change our behaviors for the future? So sometimes we could do this through human incentives. So meaning that we can incentivize humans to change their behaviors. So tax credits, other ideas, other ways. And the problem is that incentives are usually local. They're not global. So it's you doing your part, which then changes the overall global effect. It's very hard to put these incentives worldwide. So we have to act local, right? Which then stresses global. And so this is just climates, it's just showing you, this image is showing you a goat collector in Niger, Africa, and as climates have become warmer and drier, overgrazing has converted grassy woodlands into deserts. So this used to be a woodland area. You could see trees used to be here, but now, because so many people now need to herd their cattle in this area, or graze their cattle in this area, they've destroyed all the trees, and now you're talking about a forest that's turned into grassland. And that's because of humans, so lots of problems with this. So we need to monitor our progress, of course. So we need to monitor and report, providing more useful guidance for sustainable actions. What levels or amounts of these indicators are acceptable? For example, we need to, what are the levels of a chemical that we need to, be able to say are tolerated in certain resources that we use that also don't ruin the ecosystem but don't harm humans. We also need to develop protocols. We need to develop protocols in different disciplines. So for example, the natural science, mathematics, economics, political science, and the arts, we could create policies all together that'll help, that'll move things forward. And so there's just a lot of different things. The challenge is that the methodologies that we have, sustainable development cannot be met by the methodologies of any of the one discipline, is that the disciplines as a whole need to work together. So integrating learning and action. So environmental science is interdisciplinary.